Okay, so last two examples of the word problems in section 7.6, and then you're going to use these to guide you through your study plan and your quizzes for this section in my math lab. All right, so example 9, read through everything first. A contractor estimates that it would take $16,800 to make a home more energy efficient. She projects that the code built house, right, which is the one that's not more energy efficient, would have annual heating cost of $1,848. Right? She projects that the energy efficient house would have annual heating cost of $806. And the question here is, how long would it take for the annual savings to pay off the cost of the upgrades? So let's start by talking about the difference in the heating cost of the houses. All right, let's let X be what we're looking for, all right, which is the number of years that it would take to make up the cost. If we look at the difference in heating cost, then what we're going to do is take the higher cost of 1,848, that's per year, so multiply that by the number of years, minus the heating cost for the upgraded home, which are going to be $806 per year, right? And again, we're talking about X number of years. And what we need to do is look at how long it would take for this difference in heating cost to equal the cost of the upgrade, right? That's what it means when you say, how long would it take to make up for, right? How long would it take for the discount that you're getting on the heating cost to be the same as what it costs you to make the upgrades themselves? And then again, once you have your equation written, then we're just going to combine like terms and solve. All right, so I'm going to look at 1,042 times x, that's just combining like terms, is equal to 16,800. To solve, I'm going to divide both sides by 1,042. All right, that's given me a value of 16.122 and so on. All right, notice this says round up to the next whole number, because if it takes 16 and some part of a year, then that means it's going to take 17 total years to make up for the cost of performing the upgrade. In 17 years, the amount we have saved on heating costs will equal or be better than the amount that we paid to make the home more energy efficient. All right, and then rounding us out, we're going to finish with a problem that we've seen before, right, back in chapter 5. Again, I told you some of these problems are easier to do with a rate conversion than actually writing a full equation. And so this is one that we've seen before, right, when it comes to rate conversion. So we have a conveyor belt, right, that is 24 inches wide, right, so I like to draw up my pictures if I can. It's moving boxes that are 12 inches wide and 18 inches long. So, because I want to move as much as I can, all right, I'm going to note that I could fit 2 boxes at a time, right, on this conveyor belt, because each one is 12 inches wide. That means 2 can come off at the same time. And then each one of these boxes is 18 inches in length. Now, the question here is using the full width of the belt, how fast, and notice our units here, we want them in feet per minute, would the belt need to move in order to unload 6,400 boxes in an hour? So let's start with the rate that we're given, right? The rate that we're given is that we need to move 6,400 boxes in 1 hour. And let's note again where we're trying to get is to a number of feet per minute. So the first thing I want to do is convert from the boxes to a number of feet, right, using the dimensions that I'm given. So I'm going to multiply this, right? And again, what I want to cancel out is the box, right? I want to go from box to feet. So I'm going to put boxes on the bottom and feet on the top. Now, let's think about how quickly the boxes are moving off of this conveyor belt, all right? Each box, if we talk about the length of it, right, because that tells me, you know, how long it takes for that box to come off. 18 inches, I'm going to go ahead and convert this, is the same thing as 1.5 feet. So I'm going to put 1.5 feet, but I want you to notice that every time the belt moves 1.5 feet, we don't have one box that comes off. We have two boxes that come off. So my rate here is going to be 1.5 feet for every two boxes that come off. And notice what's going to happen here. All right, the boxes are going to go away, and now we're in feet per hour. So the feet's good, but we want feet per minute. So I'm going to do one more conversion where I want the hours to go away. So I'm going to put that on top. And I want minutes to stay. All right, we know that 1 hour is equal to 60 minutes. Notice that's going to cancel my hours. And that's going to leave me with exactly what I want, which is feet per minute. So again, all we're really doing here is a bit of a rate conversion. So if I multiply what's across the top, 6,400 times 1.5, divide that by 120, because that's what I have on the bottom. And that will give me a conversion to 80. And again, what's left on top is feet per minute, which is exactly what I was asked to find, right? How fast in feet per minute would the belt need to move in order to unload 6,400 boxes in 1 hour? So we started with that rate, 64 boxes in 1 hour, used the dimensions of the box and the number of minutes in an hour to convert that to a speed in feet per minute.